Welcome back, ladies and gentlemen. Here's another special edition of How Do I Do This Anyways? Today, what we're going to be doing is we're going to be looking at our histogram in terms of using the empirical rule and making sure things are within 3 standard deviations. So, um, if you did not follow and watch my prior video dealing with just making dot plots and histograms, I would suggest looking at that. These equations here are things that you will need to do in order to um, do this activity where you will need the standard deviation, you'll need the mean, median, mode, the range of your data, and you won't need that range over 7. But either way, what I'm going to do right now is I'm going to go ahead and duplicate this spreadsheet. So that way I'm not going to change anything on the first spreadsheet. I'm going to change things on the second spreadsheet. Okay. So now the first thing I'm going to change, before when I made this, I tied the bin size to this range over 7 number. Now I want to make that bin size closer to the standard deviation. So I'm going to go ahead and double click my chart area to bring up my chart editor and my chart options. And I'm going to click histogram and I'm going to change this. Okay. It was this 0.2194. Now I want it to be 0.1336. So 0.1336. And now we're going to see that it changes. Okay. We're going to see, first off, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bins. Okay. And this data point that's way, way out here is probably erroneous. Stay off the table, kitty. So, what we're going to do is we're going to start eliminating the data that is erroneous based on the empirical rule, where we're going to look at fences that are either 3 sigma above your mean value or 3 sigma below the mean value. So I'm going to go ahead and say mean plus 3 SD and then mean minus 3 SD. Okay. And now I'm going to set up an equation that will calculate this for me. So first I'm going to hit enter, or I'm sorry, equals. Then I'm going to open a parentheses and I'm going to click on the box that has my mean value in it. Now I'm going to hit minus and now I'm going to type in 3 and then times. Do not hit X. You need to use the little ampersand that's above the 8 or the multiplication sign. And then I need to click my standard deviation number. There. Now I'm going to close my parentheses and I'm going to hit enter. And it gives me this crazy number. Did I do that right? Let me see that. Oh, I did minus. Jeez, old Pete. Plus, not minus. Enter. That looks much better. Above 0. All right, now I'm going to do the same thing with 3 minus, but I'm going to get that crazy negative number now. Equals, open parentheses. I want my mean value again, plus, or I'm sorry, minus 3 times my standard deviation. With my parentheses. All right, so now what this is telling me is that according to this standard deviation for this data set that's right there, anything that's above 0.568 is outside the fences, and anything below negative 0.233 is below the fence. Well, it's difficult for us to measure a negative number with a dial caliper, so there's nothing to really eliminate here. But we can go down here to this 0.568 and look for something to eliminate from our data set. Okay, so right now I'm seeing 1.65. That was definitely not measured with our dial caliper here. So I'm going to Control C that and Control V to copy it and paste it into here. And then what I'm going to do is I'm going to be ready to delete that, but I want this on the screen. Right now my standard deviation is 1.133 and my mean is that. Here, let's do this. Delete. And now, look at that. The nice thing about Google Sheets is it automatically refresh and updated for us, just like any other spreadsheet would. So now that changed the standard deviation, which also changed my mean value, which also meant that my fences are in different spots as well. Okay, so now what I need to do, you see what happened to my histogram now, and also my dot plot. Those updated as well. The dot plot I'm not worried about too much. The histogram though, we need to update that. So we're going to double click our histogram box again, come up here, and we're going to now type our new standard deviation. I'm just going to round to the 10,000th place, and that's going to be 0.0489. Hit enter. Right now, close that on out. Still not looking too pretty according to the empirical rule, but we can go ahead and now remove a little bit more from our fences. Okay, so anything that is below 0.01 I can remove. I don't see anything there. And then anything above 0.3034. 0.3034. Okay, so these three data points, Control C, Control V, just so that way we can reference them and see them later. I'm going to delete those. And my standard deviation changed again. So I need to go ahead and I need to update my histogram bin size. 0.0176. Enter. Now that's starting to look better because our mean value is this 0.15 number, which 0.15 is right there. Okay. Our mean, median, and mode are all inside that category. Okay, that area right there, which is one of the things that should be there if it is normally distributed. Now, I still have this outlier that's way, way out here. We're talking 1, 2, 3, 4, 5 standard deviations away, 6-ish. So what I'm going to do is I'm going to look at my fences again, my upper and lower fences. I still don't have anything below. Wait a minute. Nope, I still don't have anything below my lower fence. However, my upper fence is now 0.20. So 0.2031, I can look at that and I can see if there's anything to eliminate there. Yes, those 3 points of data. Bring them down here, and now removing them. And now my standard deviation changed again. So I'm going to update the standard deviation of this chart. 0.01105. Enter. All right. Now looking at this thing, I'm seeing my mean value is 0.148, which 148 is right in here. Okay. And then 1, 2, 3 standard deviations away versus 1, 2, 3 standard deviations away. This data looks really good to me. Okay. Also, just looking at this again, although we're starting to get into some stuff on the lower end of the fence that we can actually start to eliminate now that we're 3 rounds of eliminations in, I don't know that I need to do that because this data now looks like it's following the empirical rule. It looks like it's skewed slightly positive, but it still fits within it, and it looks like it's still got more than 99, or at least right around 99% of your data in there. Now, let me click here. Okay, so 6 of them are here. You can actually look at this to determine if it does have 99.7% of the data in there. It does not, but still, it looks very good to me. So this is how you would use your standard deviation in order to clean up your data to eliminate erroneous data in your measurements. Keep in mind, you cannot get rid of all of your variations of measurements simply because regardless of what you're measuring or what you're producing, you're going to have variations in the sizes and the measurements and the numbers. It's just this is describing what is an acceptable variation. You could argue that this tail over here is not acceptable and that we need to trim it down, but depending on the precision that's required, um, it's not really all that necessary here. So that's the process that you will go through for my engineering class. I'm sure that there are better, more efficient ways to use standard deviations, but that's all we need to do here. Thank you very much. Hopefully this helped you out.